Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be looking at the 7 key separation techniques. And yes, there are other separation techniques out there, but these are the 7 that we're going to be using throughout the year and that are really important. So, let's say you have a mixture and you want to separate it into its components. Well, here's the first one you could easily use, and you use it all the time anyway, especially picky kids. So, it's called manual separation. So, what is manual separation? It's physically picking out different components of a mixture. I know I have a cousin who hates tomatoes. And so if there's a salad, he will physically pick out the tomatoes. He was actually doing a lab technique called manual separation. Some people, just don't like, I'll even give you my example here. In trail mix, I hate raisins. So I pick out the raisins. That is manual separation. And so there's a good picture. People at recycling plants do this all the time. You might think it's all automated, but it's not. Someone actually has to physically open up that bag of garbage and then pour it out onto a conveyor belt, and certain things are extracted by hand. When do you use manual separation? If something is really large, that's normally when you use manual separation. And if it's, easily sortable, so you have a heterogeneous mixture, things that are clearly different from one another. I mean, if I gave you a bag of M&Ms and I said, I want you to pick out all of the red ones for me, it would take you a little bit of time, but you'd be able to do it pretty easily. And again, often this is the very first step in a separation. Sometimes you don't even have to do it by hand. You can just, sift it through like a strainer or something, like to separate pasta from water. That's a heterogeneous mixture. Just pour it, through a strainer or a colander or whatever. And now you've got, a manually separated pieces of pasta from the pasta water. And a good example of that, sorting candies by color. If I asked you to do that. Magnetic separation. Okay, so this is exactly what it sounds like. It is when you separate a mixture using a magnet. Things that are magnetic, you want to use magnetic separation because it's really easy. You can just put a magnet in front of it and then boom, you get all of that stuff extracted out. So what do we use it for? Heterogeneous or homogeneous mixtures, but only if they contain things that are magnetic. So what are things that are magnetic? Iron, nickel, or cobalt. Those are the only 3 things on the periodic table that are metals that are going to respond really easily to magnets. So example, what if we had pieces of iron and copper and I said, hey, I want you to get all of these pieces of iron separated from these pieces of copper. You could manually separate them, right? I mean, like copper and iron look different from one another, but it would take a lot of time. Instead, if you put a magnet over it, there you go. Instantly, you get separation. Filtration. So this is when you use a funnel and a piece of paper. Sometimes it's filter paper, sometimes we use paper towels or coffee filters, it really just depends, to separate solids from liquids. So sometimes you have this, reaction and you're making a solid and you don't want that liquid stuff, so you have to separate your solid from your liquid. And so this is kind of what it looks like. You're pouring something into a flask like this, and there's a piece of paper to catch all of the solid and for the liquid to drip into. There's a little flask. So what is this used for? Separating heterogeneous mixtures of liquids and solids. If it's a homogeneous mixture, filter paper is not going to work. The paper isn't going to be, kind of fine enough for you to be able to separate everything out. So when would you want to do this? Well, you've probably done it before. This is how a coffee maker works. It separates the coffee grounds from that coffee liquid. And so if you know what you're doing when you're making a cup of coffee, that is a simple example of a filtration. But keep in mind that if you don't know what you're doing when you're making your coffee and you have solids floating around in it, you were trying to do a filtration, you just weren't doing a very good job of it. Evaporation. Evaporation is actually pretty cool. It's when you separate a solid from a liquid, so same exact thing as filtration, but instead of trying to pour it through something, you just get rid of the liquid. So you boil it. When you boil it, the liquid goes away and you're left with just the solid stuff. And so this is when you want to separate a homogeneous mixture, so like salt water. So here's an example of a leftover evaporated solution of salt water. Notice there's no water left, it's just clumps of salt. And so again, when would you want to do this? Well, it's really good if you know for a fact your solution has solid in it. It's just you can't see the solid because it's homogeneous. And so, a good example, if you have a cup of Kool-Aid, you want to turn it back into that powder again, you could totally extract the Kool-Aid powder from that nice fresh batch of Kool-Aid you made. All you got to do is boil it all away, let it dry overnight, and you'd be left with that powder Kool-Aid stuff in the morning. Distillation. This one's kind of hard to explain, but it's something that's really fun to do. So we'll do one in class. But Separating two liquids by boiling and condensing them. So if you have two liquids and they're mixed together and they're both clear, how are you going to separate them from one another? They're both clear, they both look the same, but maybe one of them, is toxic and one of them isn't toxic. So how are you going to separate them from one another? The easiest one is you can use their boiling point. Different substances have different boiling points. So what you do is you set up this weird apparatus like this and you apply heat to it. And then slowly but surely, what happens is as that water or liquid or whatever you're trying to extract in there is getting warm, it's going to turn into a gas. And as it turns into a gas, you can then condense it by putting some cold water over the top of that solution. And that's going to make it cool off and go from gas directly to liquid, and you can collect it. So this is when you're separating homogeneous mixtures again, but they have to have very different boiling points. You don't want something that's really close because if you're applying a lot of heat, you can't control sometimes how much heat you're adding. So the last thing you'd want is, oh, well, this one boils at 100 degrees and this one boils at 101 degrees. A lot of times you have something that, oh, this boils at 100, this boils at like 250 or something. So it's like, whoa, okay, that's a really big difference, and I can totally use a distillation for it. So a good example, separating alcohol from water. Alcohol boils way faster and at a way lower temperature than water does, so you can distill alcohol from water. Decantation and drying. Decanting is a fancy word for removing a layer of liquid from a mixture. Drying is exactly what it sounds like. You just leave it out and it dries. So here's a good example. Let's say I have liquid 1 and liquid 2. I could totally decant, which means pour, liquid 2 until there's none of that blue stuff left and I have nothing but liquid 1, that green stuff left. That's an example of decanting. And then if I left it overnight and it dried and now I have a solid or something, that would be drying. So what is this used for? Heterogeneous mixtures of solid and liquid. It could be something like that. Good example, you have sugar stuck at the bottom of your cup of tea, so you pour the tea in another cup and you leave the sugar behind. That's decanting, and then you're drying it out. Then that sugar is just going to turn back into a crystal again. Last but not least, chromatography, which is the hardest one to explain, but it's also one of the funnest ones to do, so we'll definitely do that one in class too. Separating a mixture by passing it through a piece of paper. So chromatography is, it can be complicated, but I guess the idea is if you have a substance that's really hard to separate, this is often your last chance of separating something. So what you do is you let, something like, I don't know, another solvent do the work for you, and you can use a piece of paper, you can use a lot of other things, but paper is the big one. So it's very hard to do, but if you have a really hard homogeneous mixture to separate, you can totally do chromatography to fix that. Often, like it says, it's a last resort. A good example, I want to separate the different colored inks and pens. I could use chromatography to separate them. Okay? So, again, that was it. If you have any questions, let me know.